Okay, well, I think we have kind of quorum to get started here. So, per usual, I'll lead off with just a brief little introduction to ResFrac for those of you who are new to the office hours, as well as the logistics. So we'll start with a little presentation today. I'm actually going to make you guys work for me, so that'll be convenient, at least for me. And then basically just an open discussion, any questions that people have, maybe motivated by what we talked about at the beginning, but also could be any other topic. There is a functionality within Zoom where you can raise your hand. So if you click the participants function, you'll get a list of participants, and then next to your name, or I think at the bottom, at the bottom, there's a little 3-dot ellipses. If you make some sort of control, either the hand or the coffee cup, I'll be able to see that you have a question and be able to call on you, and then that way we don't have 6 people talking over each other on the same Zoom channel. Okay, so the high-level overview of ResFrac is that ResFrac is a software designed to maximize the economic returns, and we do so by modeling hydraulic fracturing. The differentiator of ResFrac is that the models are capable and do simulate the entire life cycle of a well. So that means fracturing, leak-off, closure, production, and then any subsequent operations that you might have, such as refracs, which we'll talk about today, or child production, or EOR, etc. And so that model construct allows you to quantitatively optimize different decisions that you have on well design and well operation, such as cluster spacing, stage spacing, the amount of limited entry you design, etc., etc. So the key to ResFrac, as I mentioned, was that we have coupled that entire life cycle. So that includes fracture propagation. And so that entails things like the distribution of proppant, as well as where fractures are growing both vertically and horizontally. 3-dimensional flow and 3-phase flow. So that would include oil, water, gas, and we can do either black oil models or compositional models. And then the full geomechanics of production and depletion. So for instance, the poroelastic stress, which we may take a look at today, can impact then subsequent fracturing operations. So as an example, this is a 2-well simulation. On the left-hand side, I have my parent well, which I will frac and produce for 3 years, as indicated by the bright red line here. And then I'm going to shut it in and frac the offsetting child well, which is on the right-hand side, and we'll see those fractures collide in the interaction. And then we can also see that that child well produces less than what the parent did. So I'll go ahead and play the video. Here is the first stage fracking. We're going to follow that up with a second stage on that parent well. Then we're going to go into production. You'll see pressure drawn down in the fractures, and then in the matrix as well as we deplete. And then fracking the child well, you see those fractures preferentially grow into and intersect the parent fractures. And so we have very little fracture area created to the right side of that child well. So if we take it, and so that is why we would not see as beneficial production in that child well as, say, we did maybe in the parent. So this would form the basis of a sensitivity on well spacing, or maybe on changing the design of that child well to mitigate that negative impact that we are forecasting. So as a company, we both license the software as well as perform consulting projects. So today we'll leverage our experience from both of those in talking about setting up a refrac simulation. That experience comes from a breadth of basins, pretty much every major basin in the Americas now, spanning from Alberta down to Argentina. And so a final note on the conversation today, please, let's keep the conversation technical, as that's the objective of the session. And if you want to talk about licensing or consulting on a commercial perspective, just reach out to me afterwards and I'm happy to do so. So I have the wrong title in here, obviously. But today my intention was to briefly go through kind of the setup of a Refrac model. And I can't spell Refrac, obviously, as in the first bullet point. But this is, my objective is to create a couple demonstration videos to put on our website and maybe post around on Refrac capabilities, because I think that's something that's pretty unique to ResFrac. And at least in the last 4 weeks, I've been hearing and receiving many more questions regarding Refrac models and the capabilities there. So I thought I'd create a few little demonstration videos to post around the interwebs. And so I have taken a very brief first pass at that, and then hoping that those on the call can help me finish setting up the model, as well as maybe brainstorm some things that you would like to see. So what we'll do is we'll briefly cover some considerations when setting up a Refrac model. We'll look at the initial result. I've already identified some mistakes that I made. So we'll go through kind of maybe a checklist on things I generally look for the first time I run a simulation. And then we'll look at and brainstorm on how we might modify the simulation. And I can even start doing those modifications in real time if people want to see how you might change some of the setup in the model. So as I said, I'm kind of cheating because I didn't have a lot of time to prepare this week. So you guys get to help me build the model. So first, I'm going to exercise my art degree in using schematics to describe the process that we're trying to model. So the idea is that we have, and I forgot to change the text here, we'll have a original frac, which is going to be 3 clusters over a 200-foot stage length and going to be pumped at 90 barrels a minute. Then when we want to refrac, we're actually going to cement in a new liner, and we're going to do 4 clusters per stage at a 66-foot stage length, and obviously have to pump at a much lower rate because we will be going through a liner. So if we look at what's happening there, we're going to have our original fracs. Our original stage length was that 200 feet, and we have 3 clusters within that 200 feet. Then when we refrac, we're going to plug off the initial perforations when we cement in a new liner, and then we will have refrac at a tighter spacing. And so the first thing that we'll notice is, in terms of setting up a model, the stage lengths are different between our primary frac and our refrac stage. And so somehow we have to tell the computer that the stage length has changed, or maybe we can play some games in terms of how we structure that. So if we were to look at the refrac stages, you have 3 stages over the same area that you have for 1 stage in the parent well. So one of the capabilities we have in ResFrac is to frac stages simultaneously. And so the way that we can accomplish this refrac procedure is, during the primary fracture, is to call that original primary stage, actually separate it into 3 stages, but then frac all 3 together. So we will first frac stages 1 through 3. We will then go into production, primary production. And then when we go to refrac, we can frac stage 1, followed by stage 2, followed by stage 3. And in that way, we can isolate appropriately during each of the procedures. So a couple keys to setting this up is in the perforations table under well controls. There's an activation time and a shutoff time. So when we go to build the model, we can put in all the perforations and clusters that we expect, but then actually add an activation time such that initially we only can inject into those primary perforations. And equivalently, we can put a shutoff time so we can close off those primary perforations such that when we start re-injecting after 3 years, we'll only inject into the new perforations. And then for the well controls, this general constraint allows us to pump into multiple stages at once, which is a slight variance on the normal injection sequence we would use. So if I open up ResFrac here, here's my model. So I'll go ahead and edit. So here's my well. I've put it in the y-axis, as is the new convention. I have SH max currently set at 90 degrees, but if I wanted to, I could rotate SH max, and then the code will automatically rotate the mesh around those fractures. But for right now, we'll just keep those at 90 degrees. And you'll see my stages here. I have separated out one per line. However, in this model, my true stage length is actually 600 feet, as we can see down here in my perforations table. So I have perforations every 120 feet, which constitutes my first stage of my model. And over on activation time, you can see that I have put 0 for these. And then when I come back, I'm using a 66-foot cluster spacing. And here are my Refrac clusters. But again, I have the activation time set to 31,000 hours. And my shutoff time on my original perforations as 30,000. If I then come to well controls, the difference in this model versus our standard workflow is that we've now used a general constraint instead of an injection constraint. And what that means is that in this table, many more columns are exposed. So if we were to look at what a standard injection sequence looks like, the UI will format the columns to only those that you need. So if you tell it that you're injecting, it knows you need a duration, a stage number, fluid type, injection rate, proppant type, and proppant volume. And that's all that it needs in order to do that control. In the general constraint, you actually are exposed to every option you have under well controls. And so we just need to pick and choose which ones we use during an injection sequence. The reason that we use this well control, though, is that we can frac multiple stages at once. So what I've done in this example is I am fracking stages 4 through 6 as one stage. And so then I can put in my regular steps that I would use in incrementing my injection. Come over, find my injection rate. I'm going to set my production rate to 0 because I'm not going to produce while I'm injecting. I can set a maximum pressure, and then I say, what is my injection fluid? It's going to be water. Alternatively, you can see this is a very general construct, so I could have used it to inject oil or even gas. And then there's the option to add each of my proppants and my different fluids that I'm mixing to create my injection fluid. So if I come back to well perforations and open up my well, I had said I was fracking stages 4 through 6. So that would be rows 3, 4, and 5. So that means I'm fracking from minus 600 down to 0 because the stage extends until the beginning of the next line. And indeed, that corresponds to the perforations that I have set up in my model. So I will frac that all as one complete stage. And then when I go to refrac, what I have set up is to frac into each of the stages 4, 5, and 6 individually. So here I'm injecting into stage 4, then into stage 5, then into stage 6. So I'm going to inject sequentially. And if I come back to my well, I will see that was row 4, or we said 3, 4, 5, right? So my stage 6 will be from minus 600 to 400. If I scroll to my perforations, I can see that will be 1, 2, 3 clusters, right? And I have a total of 9 refrac clusters in 3 stages. So if I'm fracturing 3 per stage, seems like I have done the right thing. All makes sense? No hands, so I think we're good to go. So you can see I already caught a couple errors when I was trying last night, or beginning last night. And then this morning when I checked, I kicked off a new case, or I guess this afternoon. So we'll look at this one and see if what it looks like. And as I said, I've already caught a couple errors. So we'll kind of walk through maybe some of the initial checks that I do when I run a model. And actually, may be helpful to start by opening up one of these first ones that I ran. So whenever you run a model, one of the first things to do, and you'll actually see a warning come up in the job manager, is make sure that you've sized your matrix domain appropriately. And what we're seeing in this example is that my fractures hit the edges of my matrix, which is not very physical because I'm artificially limiting fracture length then. So when I first opened this up this morning, this looked rather peculiar to me because you can see that, come on, my fractures are artificially terminating at the edge of my matrix domain. So there's 2 possible solutions. One is either that my matrix and model domain are too small. The second would be that my fractures are too long. And so what I did on the subsequent iteration is I actually increased toughness. So if we take a look at the model that I started running this morning, what I did is I increased toughness. You can see I now have shorter fractures that are no longer hitting the edges of my model. So I'm not artificially cutting those fractures short. So that is an improvement. However, since I'm refracking, one of the other checks I want to do is that I'm actually doing the right perforations at the right time. So if I go back in time, this looks a little suspicious to me. So I promise you I did not make this mistake intentionally, but it's a good learning moment. I had originally intended to have a 200-foot stage with 5 clusters per stage. But when I look at this image, I in fact see 6 fractures have formed, and I can turn on perforations to look at where those are. And what I'm seeing is I have 2 adjacent perforations that both fractured. So this is the copy that I am editing. So I'll go in here. And look at my wells and perforations. And try to figure out what I did. So if I take a look at my image, and if I zoom out, I can figure out where my tail and heel are. So by the looks of this, it is my toemost clusters where I've had an issue. And so one of my Refrac clusters was included in my original fracture job. So my toe is going to be at 0 in terms of the stages that I am fracturing. So if I look, here are my perforations closest to 0. I should have 120-foot cluster spacing on my primary fractures. And so that would extend down to 60. Those are the first 5. And so I'll scroll over and check. And sure enough, my activation time was wrong. So I have just told the code that this perforation is open as of time 0. But it really should have not been open until 31,000 hours. So I will go ahead and save that. The other observation I had when I initially looked at this was one of the diagnostics that I think will be interesting to look at in a Refrac model is my change in stress over time. And so the way that we visualize that in ResFrac is by putting in a stress observation plane. So if we come down, we can choose delta SXX, which is the change in minimum principal stress. And you'll see that the plane that I put into my model is nowhere close to my perforations. And also I'll see that it kind of looks a little weird. If it's so far away, why is there any stress? So I'll check again and I'll plot external fractures. Oops. And so you can see I built this model by copying a previous model, and I forgot to move the stress observation plane, and I forgot to do anything with my external fracture. So what I'd like to do is put a stress observation plane through my perforations at my well level. So I want to move that horizontal plane down. And if I want to include an external fracture, I should actually move it down into and close to my perforations. But maybe just for the sake of speed, we'll move that stress observation cube. So the first thing I'll do is I'll check my well depth. My well depth is 9,000 feet. And then under output options, you can see I have a plane here where I can specify observation points and planes. I already have my plane in, so the first 3 columns are the number, basically the resolution of that plane, how many observation points I want in it. And then the next columns I specify min, max in each of the X, Y, and Z directions. And here's my culprit. My min and max Z are set at 7,800. I actually want that to be 9,000. And then also my model goes from -600 to 0. And so you can see my min and max X don't necessarily align with what my model is. So I want to change this to -600. And I'm going to think ahead here, and instead of making this 0, one of the sensitivities I want to do is actually include multiple stages. So I'm going to make this 600 because I know eventually I'm going to expand my model to be 1,200 feet long. And then I'm going to do one more thing, which is I want to add a vertical plane. So what we just added was a horizontal plane. We basically took this existing plane that was in the model and we moved it down and shifted it so that it would be around these perforations. But now I actually want to make a vertical plane so I can see how stress changes in the vertical direction as well. So I'm going to make it 1 unit wide in the X direction. Actually, no, I'm going to make it 100 wide in the X direction, 1 unit wide in the Y, and 100 in the Z. And again, my max X and min X will be minus 600 to 600. And then I'm going to center it around my wellbore. So I'll make the center 0, 0, such that it runs along my wellbore. And I'm going to go down to, well, let's take a look at how big my fractures are. So in here, I can zoom in on the fractures I have created. I will come over to other options with the 3 ellipses, and I will turn on a ruler to see where my fractures go. So if I kind of come around to the side, maybe 8,800 down to 93, 92. So to make sure I cover that extent, I will go from 8,700 down to 9,300. And what that will do is that'll put a vertical plane in the model. I can reduce file size if I'm only interested in minimum principal stress change. So I'll do that, which will just make the download a little bit faster, and it will reduce my overall file size. Again, can save, press OK. Looking over to see if there's any questions or comments at this point. Nothing yet. Okay. So I think those changes will put this model in a good place where I can start experimenting with things, just to make some videos and some quick observations. Oh, you know what? I should have looked. Oh no, I'm done fracturing out 7 days. So these fractures look almost artificially small now. So I may actually reduce toughness and want to extend the height of that stress observation plane. If I were working off actual field data, then I would have some sort of estimate or expectation of geometry that I'd be trying to history match to at this point. But instead, this is just a kind of a theoretical exercise. Okay, so I do see your comment here. And yes, I did include 6 clusters in the original frac. And I think that's why we were seeing this extraneous perforation activate, is I had listed the wrong number of clusters with an activation time. So if we save this, that can kind of be a base case. Or actually, I said I was going to make fractures larger, right? So let's go back to fracture options. And we can reduce relative fracture toughness, and that will make my fractures longer. So if I exit, it'll ask me to save. I'll go ahead and save. I really should go through and read all these warnings. I have read all these before, so I'm going to ignore them. But whenever you're running a simulation and you save, you'll see the warnings come up. Really do read each of these because they will save you from lots of mistakes. But I'm going to go ahead and press save. and then I can kick that one off as my new base case. Oh, I meant to copy this slide down. But this is now the working session where you guys get to work a little bit, which is if I were to take this and just kind of run some generic experiments to see what they look like in a model, what should I be experimenting with? So my thoughts came up with a couple. One was to extend the model. The primary frac in 3 stages of the refrac. So that would be to extend to 2 stages on primary frac and 6 stages on refrac. Also thought about changing refrac procedure. So what if we bull-headed instead of new liner and plug and perf? And another option would be, what if we changed the depletion area? So what if we added a second well? For those on the call, any requests or ideas of what would look cool in a model or what you'd like to see if it was capable of? Joe suggested maybe a sensitivity to of distance between existing or between primary perfs and new perfs. So are those perfs right next to the primary less effective? And are we basically just wasting money by fracking those and we should stay away? So then look at different refrac cluster spacings. Anyone have any wild ideas? Feel free to pipe up too. We could look at maybe. So there's a question on stage and cluster sensitivity. So we're already looking at the. You know what? Is that an autocorrect or do I have to keep putting a T on there? Refrac cluster spacing. We could also look at primary cluster spacing. Ooh, the winner. So timing of refrac. Does more less depletion matter? Probably an important one for operators would be, and this may have been part of the prior comment, would be stage length for refrac. So I think that is an autocorrect where it's adding in T. I'm just going to tell myself that at least. So the idea there would be that when we cement in a new liner, we're very limited in our maximum injection rate. And so there may be implications where your stage length could become too long pretty quickly if you're only injecting 30 or 40 barrels a minute. Vertical and lateral offset. Okay, so then well spacing landing zones of second well. So then geometry as a function of injection viscosity, crosslink, slick water, linear gel. For the Refrac. Okay, so that's a pretty healthy set of things to experiment with. I'm not going to get to all of those. I unfortunately do have a day job, but I think over the next couple weeks, this is a good list to experiment with, and can maybe share some of those during these office hours to see if we see anything cool. That's one last one here. Shots per cluster and phasing, near well, complexity, pressure drop. Cool. So like I said, you guys got to do part of my job for me, which was to think about what would be cool to model and look at. So with that, was just going to open it up to general questions, or we can do it if we want to actually see the process of implementing one of these on that existing file. I can kind of walk through how I would start changing various parameters, but do want to give an opportunity for just general questions as well. Okay, well, so extending the model is pretty easy. So that's one that is already kind of set up to do. So if I come, here's the model I was working on. So I will create, oh, well, that zoom window's in the way. I will use that to then copy the simulation. And maybe I'll keep track of that it was copy 3, but this one is going to be, I'm going to call it 2 stages, because it'll be 2 of the primary stage. So if I want to extend the model, the first place I'm going to start is my wells and perforations. And it's going to be slightly easier because I've already added the rest to my wellbore. So you can see I can actually use the new feature here to look at I think my computer is being overloaded by the screen sharing right now. So what I'll do is I don't even just stretch it. So you can see here's my current model where I've drawn a box kind of close to the toe, right? If I have a 5,000 foot lateral, what I've done is I put I guess that doesn't show it, but I put a vertice at minus 4,500, and then my stage goes from minus 600 to 0. And so you can see I've already added the vertices to go from 0 to 600. And I've assigned those stage numbers. So before we frac 6, 5, and 4, now we'll add 3, 2, and 1. And so if I just come to my perforations table, you can see it was originally 14. So what I'll do is I'll resize it to 28. And I now have a bunch of new rows. And probably the easiest way to do this is if I open up an Excel window. what I will do is I will, oh, geez, a little bit of lag on my computer right now. I will copy those existing 14, open up a new Excel window here. There's my original 14. And I can play a pretty fancy game here where I just take these and multiply by -1 and get the perforations on the other side of 0, since I have centered my well around 0. So if I come back to here, I can then paste in those new numbers, and it's actually going to correspond to where my first 5 are still part of my original fractures. So you can see I put a different number of shots per cluster. I need to scroll to get my, there we go. And the activation times, as we saw earlier. So what I'll do is I'll come down and I'll copy that entire block, come back here and paste. And now I have both my original perforations, which had 8 shots per cluster and were spaced at 120 feet. So if I come back down to row 15, here's my cluster spaced at 120 feet with the 8 shots. And then 4 shots with my Refrac clusters, and double checking I did get the activation times correct this time. Now you'll see that I'm getting an error, and it says perforation cluster is not located within the matrix region. So if I come back to my image, I'm not sure if this is going to show or not. Yeah, it doesn't show the well because there's an error and it says I'm not going to show you an error. However, we can intuit what just happened is that the original clusters went from -600 to 0, and now we've added the reciprocal on the positive side. And so I need to make my matrix longer. So you can see originally I was centered on -300 and my length was 600. So it went from -600 to 0. Now I want to center on 0, make it 1200, and I should probably double the number of elements to keep the resolution the same between the two. So I've now extended my model. If I come back to wells and perforations, you'll see I get a little green check mark, and my perforations are now located within the matrix region. Because the well is perfectly horizontal, at least the way I have it set up, there's no need to modify the Z or Y directions of the matrix. I do, however, need to come down and actually frac those stages that I added. So if I come to well controls and to my general constraint, again, I can make this process pretty easy. So I look down, there are 13 rows of my table. So I'm going to double it plus add 1. And so we'll cover why I'm adding 1. So come back, take my original 13 rows, scroll across, copy those. And I'm going to start that with a blank row in between. Scroll up, and I need to change this as well because I want to frac from stages from stage 1 to stage 3. And come here and paste that down. So I have my 2 frac sequences in there, but if I'm fracking either a single well or zippering back and forth, I'm going to have a gap in between. So what I'll do is I'll add 1.5 hours where I am not doing anything with my wellbore. And copy that across. So you'll see when I clicked out, I got a little green check mark. I no longer have errors. And then I'll do the same thing on my refrac sequence. So if I open that one up, you'll see that I have the same sequence 4, 5, 6. So what I'll do is resize my table to 84. This time I can just directly double because I have that isolation already in there. And I just realized a mistake I made on the general constraint, which hopefully I'll remediate this time, which is that I did it in the reverse order. So if we're fracking, we're going toe to heel. So what I'll first do is I will come over and copy my stages 4 through 6. Paste those in. But now I need to go back and change my original stages. So this one's going to be stage 1. I'll copy and scroll down. And then I'm going to have stage 2. Paste that in. And stage 3. And you can see it starts with 4, which I'd copied before. And so then before I get to the question in the chat, I'll quickly just go back and fix the mistake I made up here. So you can see the way I have it now is I'm fracking stages 4 through 6, and then I go and I frac stages 1 through 3. So that's the reverse of what I want to do. I want to start by fracking stages 1 through 3. And then go 4 through 6. So we'll copy those back and scroll down to paste. So I think in the matter of about 10 minutes, I have changed my model from a 1 primary stage and 3 refrac stages to 2 primary stages and 6 refrac stages. So we'll go ahead and save. I have no errors. I would want to go through and actually read all these warnings to ensure that I didn't make a little mistake, which I will do after the call before I actually submit that simulation. Okay, so the question in the chat is around how stress changes. And that is a good question. So if we go back to visualizing the result, we could look at the breakdown pressure and the treating pressures between the stages, and we can actually then visualize the stresses. Now, there are 2, stress shadow is kind of separated into 2 different components within ResFrac. Right, we have the actual stress from the deformation of rock, and that's that stress observation cube that I put in the wrong location, so we won't be able to see that. But what we will be able to see is the pore elastic stress change, which is maybe the one that the question is directed toward, which is that as we produce, SH-min is going to reduce in the areas of depletion. And so that could then impact what the pressure is when you are treating. So pore elastic delta SXX And we can see that's going to correspond somewhat with pressure. And what I'll do here is I will change it so I have 2 line plots. And what I can do is I can just zoom to different periods. So on the top, I'm going to look at my initial frac. Well, a little annoying that it's in years. So what I'll do is I'll come back up here, add a new axis, and look at water injection rate. And I could even put things like proppant concentration on there. Didn't realize I had so many proppant types in here. And then what I'll do is I'll change the X scale axis to hours and go from 0 to 5. I'm only fracking 1 stage, so it's probably less than 5 hours. And here is my plot. Then what I'll do is I can replicate that on the bottom here. Actually, first let me figure out what my scale should be. So I can zoom in to what was happening. And okay, so we start refracking at about 3.55 hours. So I'm actually going to pull this back before refrac. There we go, that's pretty close before, 3.44. And I will change my scale here. Maybe I'll make the max like 0. That doesn't help a whole lot. Maybe we'll make that 100. And we'll change the to minus 100. So you can see that indeed around my primary fractures, I've reduced stress by anywhere from 0 to more than 100 psi. And so this fracture that it's reduced in 0, it's because we've taken a slice below. If we took matrix slices and went upwards, we would then see stress around that layer. So do be conscious when you're looking at this. It does depend on what layer you are slicing through. So then if we were to look at the values, the refrac stages, well, I should probably add water injection to there so I can see when we're actually pumping. So let's look at water injection rate. Oh, zoomed me back out. Okay, so this is kind of an interesting pumping characteristic, and this is a generic model, so I don't know what may be happening here. But injection pressure actually falls pretty drastically once you are about halfway through the job. So we would have to go through and look at what's actually happening at that point. And then also interesting that this third stage has a much lower injection pressure, which we could also look at why that might be happening in the models. But if we just took that initial value, we're looking at about, we go from 13,000 down to 11.9 on the bottom hole pressure. And the original treating pressure was actually 9,000. So this is showing an increase in treating pressure, which may mean that there's still locked in stress shadow from those existing primary fractures. So once I move that initial or that stress observation plane down, I will be able to look at the magnitude of that stress shadow And that would be my first suspicion as to why you'd have a higher treating pressure in the refrac stages. Alrighty. Out of curiosity, what I'll do is I'll plot SH min and see if maybe something is happening. So instead, we're going to slice the matrix in the opposite direction now. So you can see I'm starting in a low stress layer, sandwiched kind of between two higher stress layers. So that would not suggest that treating pressure would decrease through time. I would expect it to increase when I hit the higher stress layers. So let's move forward in time. Back a little bit. So this little yellow dot tells me where I am, so I can synchronize my line plots and my 3D image. And so I'm right now at the point at which my treating pressure is reducing. Pressure. And what I can do is just go back in time and see what changes here. Okay. So that's my initial breakdown, is at that high pressure. And then as I continue to grow, my treating pressure is actually falling off, which is a little bit peculiar. Another thing to check is in my static model, if I have maybe a really high tensile strength or something that I've specified. Nope, no tensile strength. It may be a stress shadowing thing. So this is what we'll confirm when we get that stress observation plane in the right location. Again, an important point to make sure you're cognizant where you're putting that when you set up a simulation, is if I look at the point at which that treating pressure falls off, it's when my refrac fractures pass the length of my existing ones. So this is that weird one where I messed up the perforation. So we have two of the primary, and then this one here is also a primary. So if I go back in time a little bit, that'll make it clear. Okay, so those three are my initial fractures, and then I can watch the fractures grow on my refrac. And it looks suspicious to me that we see that fall off in treating pressure when the tips of these fractures extend beyond this region where I had my initial fractures. So it could be that there's a very high stress shadow in this region, which would make sense because if you remember, the toughness scaling factor I had in there was 1.0. And I had changed that to where I reduced it to make shorter fractures. So that was under fracture options. This value was originally 1.0, and I changed it to 0.75. that is going to impact net pressure and therefore stress quite a bit, or stress shadow. So a value of 1.0 is very high. And so I would imagine there is quite a bit of locked in stress shadow from wide aperture in that region. So that's my best guess at why the treating pressure reduces when we get past there. We can probably confirm that with the next stage as well. So if we look at the next reperf stage, skip forward here. So there's the beginning of the stage. There's my fractures beginning to grow. This is the point right before I have that fall off in treating pressure. If I go one step farther, indeed I have started passing, although this one's still parallel, but maybe it's also seeing this area over here. So that is my first suspicion, but when I rerun it with that new observation point, I can confirm that next week when we all log in. So with that, we have gone a few minutes late. Sorry, wanted to finish that thought, or even though I didn't reach a conclusion. Any questions or thoughts as we wrap up here? A little bit of an unconventional office hours this week due to everyone being quite busy. I think it is a developed skill to be able to speak to a silent audience. It's very discomforting. Oh, well, thank you. I did get an applause, so that was always makes you feel warm inside.
It's a good job, Garrett. It's tough to do on the fly, and you went through a whole lot of steps there. So hopefully everybody's able to hang in there and follow with that. But I just wanted to let everybody know we have breaking news that the Tiger King's attorney has asked Trump to pardon him. And the Tiger King was one of the original themes that we started this. So wanted to make sure everybody knew that.
Joe was paying attention during this whole thing. I can see that.
Yeah. Clearly, I was captivating. So I guess a final thought would also be to solicit feedback if people found kind of that helpful of me just kind of stream of consciousness walking through changing a model. I don't have a great sense of whether that was helpful or boring, but feel free to leave a comment or send me an email, and that will hopefully inform future sessions as well. Or if you want to offer legal advice to Joe Exotic, you're welcome to do so. Well, thanks again, everyone. As always, I'll stick around if anyone wants to poke fun at me or text a question, but look forward to seeing you guys next week.